In this video we will be looking at mathematical functions. A function is a relation where every x value has at most one corresponding y value. So that means that a function is a rule that assigns each x value a maximum of one y value. So it can have none or only one y value for every x value of the rule. To put that another way, no two ordered pairs in the relation contain the same x value. From our knowledge of relations, the only types that qualify as functions are one-to-one relations. So an example of that is a linear graph, such as y equals x, and many-to-one relations, for example y equals x squared, or a quadratic relation. The vertical line test can be used to determine if a relation is in fact a function. So if a vertical line can be drawn anywhere on the graph and only cut the relation once, or at most once, then the relation is said to be a function. So a parabola passes the vertical line test, which means that it's a function. So we can draw this green vertical line anywhere along that relation and it cuts exactly once, and that's what makes it a function. A circle, on the other hand, fails the vertical line test because there is at least one x value, in fact there's lots of x values, where the vertical line drawn through that point intersects the relationship twice. So that means that it is not considered to be a function. When we define a function, it's fully defined by a rule and a domain. So there's two things you need to include when you fully define a function. So we can fully define a function f using this notation below. So this notation reads f, the name of the function, such that the domain maps to the codomain for f of x equals a certain rule involving x. So f, as we said before, is the name of the function, and we'll generally use a lowercase letter such as f, g, or h to name a function. The domain of the function must be specified, and that's specified in this position here. And we generally use interval notation to represent the domain of these functions. Remember that the domain can either be maximal or restricted, but either way you have to write it into your rule. The codomain is the set of values that x is mapped to. So the range of f must be a subset of the codomain. For VCE mathematical methods, the codomain is always considered to be the real number system. The notation of f of x replaces y equals when we describe the rule. So instead of y equals a rule, we now have f of x describing the rule. As we previously mentioned, it is possible to restrict the domain of a function. So to restrict the domain, we simply specify the restricted domain when we define our function. So here are two examples. The first is y equals x squared, for x is an element of the real number system. So that graph is unrestricted and it would look like this. The second one, we have y equals x squared, but this time it is for the restricted domain of x is an element of -1 to 2, where -1 is included but 2 is excluded because of the brackets. And when we graph that, this graph is a restricted graph, only part of the graph is appearing. So we can see that at -1 the point has been included because the dot is coloured in, and at the point 2 it has been excluded because the dot is open or not coloured in, which indicates that the point is excluded from that graph. So next we want to consider the function f, such that the domain is -4 included to 2 not included, and that maps to the set of real numbers for the rule f of x equals x squared plus 4x. Our first task in part A is to determine the value of f when x equals 2. So to do that, we can write f and replace x with 2. So we're going to evaluate the rule at x equals 2, which will be 2 squared plus 4 times 2. And that is equal to 4 plus 8 equals 12. Next, we want to solve the equation f of x equals 0 for x. So if f of x equals 0, that means that x squared plus 4x is equal to 0. So this is a quadratic equation, so to solve this we can factorize. So we take x out as the highest common factor and we're left with x plus 4 is equal to 0. And then we use the null factor law that says x could equal 0 or x plus 4 could equal 0. So x plus 4 equals 0, we subtract 4 from both sides to get x by itself. and we find that x equals -4. For part C, we want to sketch the graph of f, clearly labeling any axial intercepts, endpoints, and the turning point with their coordinates. So the first thing we can do is have a look at the endpoints. So our first endpoint is x equals -4, and when x is equal to -4, we know that the equation f of x is equal to 0. So that will be this point here, and it's coloured in because the point is included because we have a square bracket up here. So this is going to be the point -4, 0. Next, we know that the graph is also at 0 when x equals 0. So we know that it will pass through this point, which will be 0, 0. Finally, the graph ends at x equals 2, and when x equals 2, we know y is equal to 12. So this graph will look something like this, where our endpoint at 2 will have an open circle because that point is excluded because of this rounded bracket, and that is at 2, 12. The last thing we need to find is the turning point of this graph. And because a parabola is symmetric, we know that the turning point will occur at -2. So that'll be this point here, -2, And to find the function's value when x is -2, we can evaluate f of -2, which is going to equal -2 squared plus 4 times -2. So if we evaluate that, we find that -2 squared is +4, then we'll have subtract 8, which will give -4 as the f of x value. So this will be -2, -4. Finally, it's important to note that if the axes of the graph are not labelled for you, you must label them with the correct variables. So for the horizontal axes, we have x as the variable, and for our vertical axes, we have f as our variable. So we put f as that label. So after this video, you should be able to understand that a function is a relation that maps every x value to, at most, one y value. You should be able to use the vertical line test to determine if a relation is a function. You should be able to fully define a function, which is a rule and a domain, using appropriate function notation. And you should be able to understand that functions can have maximal or restricted domains. Finally, you should be able to graph functions over their specified domain, whether that is maximal or restricted.